Welcome back. We now will proceed with our last panels of the day. Again, because of our cancellation due to the weather yesterday, we are completing the hearing in one day, and that has meant that we are combining the appearance of panels 4 and 5. They're still focused on their discrete subject matter, but they will all appear before us today in this evening session. I'll turn it over to Mr. LeBaron.
Thank you, Chairman Hersman. So the combined witness panel 4 and 5 is composed of the following individuals from my left and nearest the Board of Inquiry. On the first row, we have Mr. Mike O'Donnell from the Federal Aviation Administration, Assistant Deputy Chief Dale Carnes from San Francisco Fire Department, Jason Shively from Oshkosh Corporation, Mr. Mark Tunnicliffe from the Federal Aviation Administration, and Chief David Whitaker, retired from Aircraft Rescue and Firefighting Working Group. On the second row, starting on the back left, is Mr. Richard DeWeese from the Federal Aviation Administration, Mr. Jeff Gardlin from the Federal Aviation Administration, Mr. John O'Donnell from Air Cruisers, and Mr. Bruce Wallace from the Boeing Company. The NTSB technical panel is composed of, starting on my right, Mr. Bill English, Mr. Chong-Kwan Park, and co-leads Mr. Pete Wentz and Miss Emily Gibson and Mr. John DeLisi. I now ask that the witnesses please stand to be sworn. If you'd raise your right hand, please. Do you swear or affirm to tell the truth? If so, answer, I do. You may be seated. Chairman Hersman, these witnesses have been pre-qualified, and their respective experience and qualifications appear in the docket as exhibits in Group 1. As discussed during the pre-hearing conference, during this round of question by party representatives, Mr. Rob Hinches will act as the party spokesman for Air Cruisers. I now turn the questioning over to Mr. Peter Wentz.
Thank you, Mr. Blair. Mr. Hooray, if you could please bring up Exhibit 6V, Mr. Carnes' presentation. And when we get that up, Mr. Chief Carnes, if you'd like to start with your presentation at this time.
Yes, sir. Thank you. Good evening. I'm Assistant Deputy Chief Dale Carnes of the San Francisco Fire Department, and I'm in charge of the Airport Rescue Division at the San Francisco International Airport. This evening I've prepared a brief overview of the ARF and emergency response to the Asiana 214 crash. The initial impact for Asiana 214 occurred at 11:27 hours. Approximately 12 seconds later, the FAA tower dispatched an Alert 3 in progress to all 3 fire stations. At 11:31, 2 minutes after being dispatched and 3 minutes after the initial impact, the first ARF unit, Rescue 88, arrived on scene, followed 37 seconds later by Rescue 9. Upon seeing that the initial passenger egress paths on the left side of the aircraft were not threatened, both units immediately attacked the fire in engine number 2, which was resting against the right side of the aircraft. By 11:33, a little less than 6 minutes post-impact, all 7 airport firefighting companies and 2 paramedic units were on scene. Paramedics were beginning to collect casualties and initiate triage. Approximately 1 minute later, the first of 56 ground ambulances arrived on scene. At 11:38, ARF personnel entered the aircraft for interior search and rescue. By 11:46, all trapped passengers and those who had remained behind to assist had been removed from the aircraft. And by 12:18, approximately 19 minutes after the impact, all fire in the fuselage had been extinguished with the support of companies from San Francisco and mutual aid from San Mateo County. At 13:01, the last patient from the airfield was transported by ambulance. All ambulatory passengers had been relocated to the terminals, and a significant number of those passengers later self-reported injuries and underwent secondary triage. By 17:58, the last of those passengers were transported from the terminals to area hospitals. All told, 56 ground ambulances, 2 medical helicopters, and 2 buses transported 179 patients to 12 area hospitals. There are many areas of this incident that we consider to be successes. Among them are the arrival of ARF units within 3 minutes of the initial impact and without prior alert notification. The extinguishment of the fire in engine number 2, which was wedged against the right side of the aircraft, in 90 to 120 seconds. The rescue of all trapped passengers extrication of all those trapped passengers from the aircraft within 19 minutes of initial impact and prior to the arrival of mutual aid resources, and the extinguishment of all fire within 47 minutes of the initial impact. And this includes a large interior fuselage fire that initiated and rapidly spread within an area that could not be effectively reached by interior hose lines. In spite of our successes, we feel that there are many lessons to be learned here. And just some of the areas that we have focused on for improvement are large incident management of large-scale ARF incidents, managing a large survivor population in the midst of an ongoing firefighting and rescue operation, locating and collecting non-ambulatory injured over a large accident scene, compatibility among radio systems of responding agencies, fighting interior fuselage fires where the effectiveness of interior hose streams is severely limited, and the effective use of the high-reach extendable turret, or HRET, and piercing nozzle. To that end, we have pursued the following post-accident initiatives. To enhance our training program, all personnel have received an additional 40 hours of ARF training provided by personnel from the Dallas-Fort Worth Fire Training Research Center. Advanced ARF training for all officers will begin in 2014, and we have adopted the DFW HRET training curriculum. Also in 2014, we'll be bringing in the Blue Card Incident Management Training System to train all officers, and we are currently implementing the EMT3 triage system to enhance our mass casualty incident management capabilities and to ensure that our system of dealing with MCIs is seamless with the other agencies in San Mateo County. Also in the area of EMS, we are upgrading our EMS supervisor's position to 24/7 status, which will further enhance our incident management capabilities in the medical branch. We have budgeted for a dedicated mass casualty vehicle to be housed in one of our fire stations. We have improved radio interoperability between ARF and mutual aid resources. We are developing strategies to lessen the potential for firefighting vehicles impacting accident victims. We are adopting the Passport Accountability System for tracking all fire and EMS personnel on scene. And we're actively developing policy and procedural guidance in both the administrative and operational levels. And lastly, we have increased both our communication with and our involvement in the mutual aid community to include multiple debrief sessions with surrounding agencies. Again, sir, these are just some of the initiatives we've put into place, are currently working on. And this does conclude my presentation.
Well, thank you, Chief Carnes. We're going to start in with some things, and Mr. O'Donnell and Mr. Tonacliffe, some of the FAA questions that I'm going to ask you, if it's not your general area, and it may be Mr. O'Donnell's, just feel freely between you to say, you'd rather take the question. But what I'd like to start off with is, talking about the San Francisco airport. And I know that, as our standpoint says, there's different indexes. Could you talk about what type of an index the airport is and, what qualifies it to be that index?
Thank you. The 139-315 describes in it that the length of the air carrier aircraft and the average daily departures determines what the index is. San Francisco is an Index E airport, which is the largest serving aircraft over 200 feet in length.
What about certification, FAA certification? What type of rules or policies do you have to have in place for an airport of that size?
That's good. Good evening. Certification really is based on Part 139, which is a regulation which covers commercial service airports. There's 540 of them in the United States, and really it's based around the self-inspection program that we hold the airports to. It's a higher level of safety than you would find at a general aviation airport. Aircraft rescue and firefighting is just one piece of it. It could be snow removal. It could be vehicle operations, marking, lighting, signage, all the things that occur on the taxiways and the runways are basically governed under Part 139. So it's an overarching regulation, but at the core of it is a self-inspection program where the airport daily inspects its own airport movement areas and notes discrepancies. The ARF training is also a big piece of that, and there are requirements under the regulation for ARF training, vehicles and equipment, and the index as well.
Okay, thank you. Chief Carnes, I'm going to ask you, on the day of the accident, what was your staffing levels that day for personnel and for equipment?
At the airport, we have 3 fire stations spread strategically throughout the airport. We maintain 7 firefighting units, including 4 ARF vehicles. Each one of all 3 of our 4 ARF units are staffed with 2 firefighters. Our 4th ARF unit is staffed with 2 firefighters and 1 lieutenant. We have a similar staffing on our other companies, so we generally have a daily staffing of approximately 23 firefighters or ARF personnel and 1 shift commander, which is a captain.
In your presentation, you spoke about mutual aid. So after the incident happened, then you called it, you said mutual aid came to support you. How does that system work?
Well, we operate under the California Master Mutual Aid program, and we work within Region 2. The state is divided into 6 regions. We function in Region 2 and regularly work with our allied agencies, both providing and receiving mutual aid. In this case, in the event of an actual Alert 3, we automatically request mutual aid from San Mateo County and additional companies to respond from the city. We use a system that's referred to as a box system. The box is nothing more than a predetermined or pre-designated response package, and in which case we get several companies from both the city and from San Mateo County, and both with their own independent command element coming with them.
Chief Whitaker, I have a question for you about once an incident like this happens, and as Chief Carnes said, the Alert 3 went out. They start heading to the scene. How does the fire department set up on an accident scene?
Thank you, Mr. Wentz. And per your instructions, I'll try to remain generic and not specifically speak to this accident. Most airport fire departments have developed standard operating procedures and guidelines, and one of those is the CERT pattern, or the Standard Emergency Response Pattern, which is based on a clock system. And it's important to predetermine where many of those incident command positions will be for future oncoming companies, mutual aid companies, and others from outside the airport environment that certainly aren't familiar with some of our setups. Those CERT patterns are typically based on wind and terrain. Also, time of day, weather, and other factors like that play a role. So once the firefighters have trained on a CERT-type pattern, and whether it's a clock system or based primarily on wind, they know predetermined locations as to how to set up on the aircraft, whether it's on fire, whether it's passenger or cargo type of aircraft, whether passengers are self-evacuating, whether they can see smoke, and many other factors the incident commander has to make and decide in those first 3 or 4 minutes. And positioning of that equipment in those early stages of this incident is critical, because if you allow many companies to box up into those areas, then sometimes you're not able to maneuver them or reposition them as if the incident escalates.
Okay, thank you. Mr. Tonnicliffe, when it gets back to, talking about an airport of this size, what type of training is required from the ARF or the fire department?
The 139-319 provides what I like to call the dirty dozen. It's 11 subject areas, and then you also need to have an annual recurrent fire training in a pit. To go along with this, the FAA also has an advisory circular which we expand upon the different areas of the 11 subjects of required training.
Is there any difference in, say, initial training to a recurrent training for a firefighter?
The initial training, as long as they get your dirty dozen subjects, and the recurrent training is the same. There is what Chief Carnes, what the Chief talked about earlier in the 40-hour class, that gets the individual a lot of the training up front initially.
And who does or checks the oversight from the FAA's point of view if these training has been met?
We have airport certification safety inspectors that go around to the airports annually and inspect the training records at the airports of the ARF personnel.
Okay, thank you. Chief Carnes, of all the training that goes on in San Francisco, how are your training requirements implemented for your firefighters?
We actually have a multi-layered training program. We meet the requirements. Our training delivery comes in the form of daily company drills, weekly what we call captain's drills, monthly red cap drills, which are multi-company, basically involve the entire shift that we have 3 times a month, as well as ongoing specialized training and our annual live burn training.
In, say, just a few seconds, could you tell us what a red cap drill entails?
Well, a red cap drill, again, is we use it to capture several layers of training. We use it to do our time trials to make sure we're meeting our response times. We also practice runway crossings under Alert 3 conditions. Depending on they're always scenario-based drills, so depending on the scenario, we will, and where we're staging the drill, we will also practice positioning of our apparatus, basic incident command, implementation of the HRET, etc. We try and wring as much training value out of them as we can.
Okay. I'm going to transition a little bit and move on to fire scene management now and talk about incident command. Chief Whitaker, can you explain the incident command system and how it operates?
The national standard is the NIMS, National Incident Management System. Of course, taught originally through the National Fire Academy and Emergency Management Institute and local state agencies as well. The 100-200 series is the lower level initial learning, and the 300-400 levels are for your higher level incident managers. In the fire service, we always use an incident management NIMS type system, even on a daily basis on our small. If you have 2 engines and a truck and an ambulance responding to a house fire, then we establish command and go through some of those initial steps. That way the firefighters are used to hearing those commands and understand the different terminology within the NIMS system. And so on a larger scale, more complex incident, as the NIMS system allows you to expand and put operations and medical and different branches and different divisions in place, the firefighters understand that terminology and they understand the direction and who they report to within this system. And, of course, as the incident begins to stabilize and you're able to, retract the NIMS positions, it works the same way. But when you call for command, it doesn't matter whose voice you hear, whether it's the captain or the chief that is taking his place. You call command, you ask for or request the resources that you need, and they're provided to you.
So, Chief Carnes, on the day of the accident, who was your initial incident commander?
Our initial incident commander was the on-duty shift captain that day.
So, for each each shift you have an on-duty captain that takes that role on?
Yes, sir.
And as Chief Whitaker was saying, it sounds like as it escalates and get larger, your incident command can get larger as well?
Yes, sir. And generally, the way we work is that our on-duty shift captain is the initial incident commander, meaning that once he gets on scene, he establishes command, establishes his command post, declares his strategy, creates an initial incident action plan, initial assignments, and orders additional resources as needed. Obviously, in the event of an actual alert 3, then that's done automatically, and we get a considerable amount of resources coming in. As Chief Whitaker alluded, the system is designed to expand based on the size and complexity of the incident, and an alert 3 that involves firefighting, rescue, and a mass casualty incident is a significant and complex event. Because of that, we've already prepackaged into our response, our box or response package from the city, not only a number of engines and truck companies and ambulances, but also a sizable command presence in not only battalion chiefs, but also more senior assistant chiefs that respond, and then assume command upon their arrival, take over the strategic command role, and then place the on-duty shift captain in a more operational or tactical level command, concentrating on the ARF operation.
So on this day, then, you had somebody else take over control of the incident command?
Yes, sir. The assistant chief who was in charge of Division 3, which is the south end of the city that day. Okay,
and so what could you kind of talk us through what a handoff would be then when that chief got on scene?
Upon arrival, the chief would report to the already established command post, and he would get a structured report from the initial incident commander that would include the incident conditions, the status of all their resources they have on scene, and any resources that have been ordered or requested, the initial incident action plan, the primary tactical objectives that have been established and or met, and any concerns that the initial incident commander might have.
So I guess that's a normal practice every day that you see, no matter what type of a fire it is. It doesn't have to be an aircraft fire.
Not only is it normal, it's routine for us. Our department runs a little over 10,000 calls a month, with a large number of those being working fires, including what we call greater alarm or multi-alarm fires in a very complex urban environment. So what that means is our chief officers are very experienced, very capable incident commanders. So that process, not only is it spelled out very clearly, very structured in our command post operations manual, but it's something that it's a procedure we practice on a routine, weekly basis.
Okay. Chief Whitaker, I'd like to talk a little bit about on-scene safety. ARF rigs are very large rigs. There's a number of them around the scene at the time. What do you do to practice safety with other firefighters, the police, the airport safety officers, passengers and crew that are around the aircraft in maneuvering these aircraft, or the ARF rigs, excuse me?
Well, through our initial and recurrent training of operating these vehicles, we try to maintain monthly mini drills with the different agencies on the airport, including operations and police, medical, fire. Different airports are certainly set up different ways. We were a municipal department that serviced the airport, but I know in many other airports, whether they're Port Authority or they rely on outlying companies, they do it different ways. But we would train primarily without the luxury of having hundreds of people on the scene. We would call it functional drills or mini drills. And so we would set these trucks up and set up different positions, whether it be cones or other type of equipment, have the drivers maneuver these vehicles, raise the high-reach extendable turrets, raise the booms, spray water, try to put them through different situations that they may encounter with different types and sizes of aircraft.
When when you talk about this operator of this rig, I know that in some of the interviews that we have, there was a rider along with them, and some they don't. How much more does that place on the operator without a rider in the rig with them?
You know, we were fortunate that we rode 3 to a rig. I know many places ride 2. But when you're a single operator of these type of rigs, you know, 35, 40 feet long, limited visibility in some cases, especially behind you, or trying to monitor a camera. At the same time, you're operating 1 or possibly 2 joysticks, operating the bumper turret as well as a high-reach extendable turret. And if the officer or the second person off that vehicle is committed to pulling hand lines or doing search and rescue, and that operator is by himself attempting to operate those radios, not just to his fire department, but to the FAA tower or operations, it's quite difficult and quite complex for one person to assume all these roles and tasks. So it's for that driver operator to monitor his extinguishing agents, to maneuver the vehicle, to again, a multitude of things that he has to do alone in that cab once that second person leaves the cab is quite difficult.
Mr. Tunnicliffe, what kind of guidance does the FAA provide the fire departments about moving ARF rigs?
The FAA has Advisory Circular 150 5210-23, which deals with aircraft rescue firefighting vehicles, primarily the high reach. And within there, we have in the appendix, there's actually something that is like a test that they can go through as an example. We provide an example for driver skill ability, and we do recommend that they have a backup man. We also have a couple ARF training DVDs that we provide to the certificated airports.
Thank you. Chief Carnes, in your opening presentation, you spoke about challenges with communication. Could you talk a little in depth about that?
Well, prior to July 6th, the city and county of San Francisco had invested a lot of effort and money to enhance and improve the radio communication systems for the fire department. $7 million alone, I believe, was what we spent at the airport, with the goal of having interoperability between the different elements within the city and county, meaning that units at the airport would be able to talk to units from the city and also ideally mutual aid resources from San Mateo County. That development process was still underway when the Asiana 214 accident occurred. And because of some recent rebanding of radios that was part of that process, we weren't ultimately able to have those elements communicate on the same radio frequency. Most large-scale fire incidents that I've been on, communications is generally one of the challenges we face. Because of that, we're used to dealing with it. It was something that we were able to overcome rather quickly. One, by falling back on what additional frequencies we had available to us, as well as face-to-face communications when necessary, and also because of prior established relationships between our chief officers and the chief officers from the mutual aid agencies that came into the airport. That ability to have those relationships already in place and set up a unified command really allowed us to overcome that challenge without any negative impact to the incident.
So you kind of made changes on the fly that day to make it work for you. Have you made changes to fix the system as a whole?
We've made a series of changes. Primarily, we now have the ability to patch fire department radio frequencies from the city of San Francisco and from mutual aid resources in San Mateo County directly onto the radio frequencies at the airport. So we now truly have interoperability where we can all communicate on the same frequency. And our goal that we plan to reach in 2014 is to be able to do the same with San Mateo County EMS.
Okay. I'm going to transition now to talk about tactics and the piercing nozzle. Mr. Shively's been sitting there waiting for a question, I'm sure. So Mr. Hooray, if you could bring up Exhibit Q, Photograph 1, and Mr. Shivey, if you could briefly describe the high-reach turret and the piercing nozzle.
Yes, sir. The high-reach turret is a device that's mounted on the vehicle to deliver agent to the fire scene itself. I may use the term snozzle throughout my presentation here. That's the brand name of the high-reach turret from Oshkosh Corporation. So if I confuse ATRET and snozzle together, you know where I'm talking about. The ATRET itself is mounted at the top of the vehicle. In the photo up there is the white boom. There's two sections to the boom. There's a lower boom and an upper portion. At the base of the boom on the vehicle, there is a pivot mechanism that allows the vehicle to, or allows the snozzle to be moved left and right. At the tip of the upper boom is what we call the head. That is where the primary water foam nozzle is located. Inside that upper boom is also an inner boom that is extendable forward to exchange the reach of the nozzle itself away from the vehicle. Also on the end of the head, there's the ability to have the airport specify different options. We can put lights at the end of the head, color cameras, infrared cameras. We also have the ability to discharge auxiliary agents, whether it's dry chemical or a clean agent. And then also there's a piercing tip that can be specified by the airport that's shown in the red tube on the photo up above. Can we move to photo 5, please?
Mr. Hooray, could you find, it may take him a second to find it, but go ahead and while he does that, so why was the piercing tip developed?
Well, to kind of continue on my previous comment, the boom itself allows the operator to put that in the water nozzle away from the vehicle into a better position, depending on conditions, than a standard mounted roof turret. So the boom is actually able to raise up. So if there's a high mounted engine, that's not the one I was looking for. I was looking for one that had a boom raised.
That's true. I believe it's the one with the last one in there with
might
the
be
two.
number 6.
And how long has, is this your?
Yep, that's the one. So this photo here shows the boom raised up in the horizontal position up above, and then it also shows the piercing tip deployed. This photo does show we offer 2 different lengths, a 50-foot and a 65-foot variant that can be chosen by the airport for their particular needs.
And who operates this?
The controls for this are located in the cab. In the Stryker vehicle, the operator sits in the center of the cab. On the right-hand side is what we call the officer seat. And between those two is where we have the controls for both the roof turret, the high-reach turret, or the bumper turret, depending on what's specified with the vehicle. So at any point in time, the operator can move to his right to operate it, or if there's a person in the captain's chair or officer's chair, he can move to his left to operate it.
Okay. When you deliver a vehicle like this, what type of training comes with it?
From a basic standpoint, and I can talk in specifics to the SFO delivery, which is very common to our typical deliveries. Typically, there's a 2-week class that is involved. The truck is delivered to the airport. We dispatch Oshkosh representative to the airport. The first week of training is basic training on the vehicle itself and its operation, and the second week is centered around the snozzle. So the 2 vehicles that were delivered to SFO that had snozzles received 2 weeks of training. There was a 3rd unit that was delivered in 2010 that just had a roof turret. That vehicle received 1 week of training.
Okay. And Chief Carnes, how were the penetrating nozzles used in the Asiana accident?
The penetrating nozzles or the HRET as a whole? We used the HRET both as an elevated master stream, similar to what you saw in that one picture, after the fire had breached through the top of the fuselage, and we also used the piercing nozzle component. We pierced the aircraft 3 times.
And who decides to do this?
Well, we have the option of a couple different people making that decision. Obviously, our lieutenants, our company officers, are responsible for task level supervision, However, our driver operators are also fully trained and capable of making that decision in the absence of direct supervision.
Mr. O'Donnell or Mr. Tunnicliffe, what type of FAA guidance is there when it comes to piercing nozzles?
Again, as I stated previously, the FAA has published Advisory Circular 150-5210-23. Within that, we provide guidance on use of the high-reach extendable turret. We don't directly tell them when to pierce, but we do provide information about piercing. There are two different types of penetrating nozzles that are currently on the market, and Oshkosh provides one of them. They operate in different manners. But we do provide guidance on how to pierce, but we don't provide any guidance really on when to pierce.
And for Chief Carnes, excuse me, in some of the interviews, we saw some hesitancy to when to pierce the aircraft. There were talks of people still inside the aircraft. Could you talk through that for me?
Well, I don't think so much it was hesitancy. Our personnel are trained from the beginning of their career to never conduct exterior fire attacks simultaneously with interior fire attack. In this case, through the early part of the incident, we had both trapped passengers and personnel inside the aircraft extricating those trapped passengers. So, again, I wouldn't characterize it as hesitancy. I would say that it was a tactical decision made based upon their training and their experience and good risk management to wait till those personnel had been extricated. They'd extricated the passengers from the aircraft and the personnel had evacuated the aircraft to go ahead and start piercing and employ an exterior attack.
Okay. Mr. Shively, in one of our exhibits L, it's the video from the tower that day, and it showed our vehicle backing up and the piercing nozzle was hanging from it. So it seemed that nozzle had broke. Can you explain to us why that happened?
Sure. The piercing nozzle, in just its name, is developed to pierce the fuselage, much like you would take a pencil and insert it into a soda can.
Mr. Shively, could you speak more directly into the microphone, particularly for our interpreters?
Okay, thank
you.
So with the piercing nozzle, it's designed as a tube with a sharp point on it that's allowed to pierce the side of the fuselage, dispense the agent on the interior of the aircraft. With that being said, there is no cutting mechanism to it, so if there is any relative motion between the piercing tip and the fuselage, that would put force into the boom itself. To protect the integrity of the boom and the head, we allow that piercing tip to shear. In the video that was from the scene from C-225, the rig R-10, I believe, was the one that pierced it. Then it broke as it was being extricated. That vehicle was allowed to go back, refill with water, return to the scene, and they continued to use the vehicle with the high-volume nozzle to fight the fire after the fact.
So the tip is actually designed at some point to break, and that would be a normal function if it got put into a position where it was going to snap anyway, or?
Correct. There's always a risk of when the piercing nozzle is pierced, the ability for that to become lodged or stuck. So we allow that to shear itself if there is a side force put on that nozzle that we don't expect. That serves or protects the integrity of the boom and the rest of the piece of equipment so it can continue in further use.
Okay, great. We're going to transition now to the rescue portion of this. And Chief, if you could, Chief Carnes, excuse me, if you could talk to us about the rescue portion that went on that day.
Well, we had at least 4 trapped passengers in the aircraft, and we also had a number of passengers and non-fire airport personnel that were inside the aircraft trying to assist. And so immediately upon, as I explained in my presentation, the first in units, they addressed the first priority of ensuring that the egress pass of the passengers was safe and protected. And then once that was complete, the passenger evacuation, they then went to their next priority, which is life safety is always our highest priority, and that involved rescue in this situation. Because of the fact that we did have fire that was extending into the fuselage, we also took hose lines into the interior aircraft to support those rescue efforts and protect our personnel.
So, in total, how many personnel did you have inside the aircraft that day?
Not all at the same time, because the rescue effort went on for several minutes, but we had a total of 9 of our 22 personnel that were inside the aircraft at any one time during the rescue.
Either Mr. O'Donnell or Mr. Tonacliffe, if you could quickly, I know that from the American Airlines 1420 accident, there was a recommendation 0165 on the numbers of ARF rescue personnel available. Could you talk a little bit about that?
Yeah, I'll talk about that. So under Part 139, we don't get into the details of numbers of firefighters that have to be on a department to respond. We do talk about sufficient and qualified firefighters are able to operate the vehicles, that are able to meet the response times, that are able to dispense the minimum amount of agent per the regulation. This topic has come up many times before. We've looked at it through the Airport Cooperative Research Program, at least 2 separate studies to define what, if there are any appropriate levels of staffing that could or should be mandated for airports. And the studies were conclusive that the costs to implement something like the proposals we've had over the past 5 years of having requirements for firefighters or requirements for certain specific types of numbers of vehicles far exceeded the benefit versus the cost. So in any rulemaking that we would have to initiate to change this regulation would be based on whether it's cost benefit or not. The 2 studies proved that it was indeed much more expensive and not cost beneficial to go into requirements of some of the recommendations that have been out in the past with the numbers of firefighters that have been proposed in previous FAA bills. So we have kept the regulation where it's at. The regulation is pretty clear that sufficient and qualified people to do those things that I just mentioned are tested annually with the certification inspection that occurs at the airport.
Okay, we're going to move on to triage. Mr. Tonacliffe, if you could talk about MASH casualty and what airports do from the FAA side for triage.
The FAA requires the airports to hold a triennial drill. Every 36 consecutive calendar months, they must hold a mass casualty drill in which they test and implement their full system at the airport with some type of drill. Mass casualty is one of the drills that they hold. We like to see it with an aircraft, and that's
okay. Chief Carnes, do you know when the last drill was conducted in San Francisco?
For at least the last decade, the San Francisco International Airport has chose to conduct our large-scale mass casualty drills on an annual basis instead of a triennial basis. The one exception, or 2 exceptions actually, one would be this year because we had the actual Alert 3 incident. And in 2012, we actually switched up the scenario on our mass casualty drills so that it was a off-airport scenario, that the aircraft had went long and actually landed on the outskirts of the city of San Bruno. So, but in general, again, we do that annually every year and have for at least a decade, and it involves all the mutual aid agencies in San Mateo County, as well as the units from the city of San Francisco that were involved in the Asiana 214 crash.
Mr. LeBaron, I see I'm down to the manager. I've got one last question, if I could. Could you describe how the triage went that day of the accident and kind of take us through, from the rescue onto the triage, how it went through on that day?
Well, the objective of triage, the short answer is to do the most good for the most people. Basically requires that our first arriving paramedics organize the casualties into color-coded groups that are based on their level of acuity. It involves a very rapid, approximately 1-minute assessment, assessing their respirations, their perfusion, and their mental status. Based on the findings of the assessment, again, they're categorized into one of 4 categories that are, again, are color-coded. Red would be immediate, or those that are most critical and whose survival depends on surgical intervention in a rapid fashion. Yellow would be delayed. Those are seriously injured but not as critical as the immediate category. Green would be walking wounded or minor injured. And then black would be those that are dead or expected.
Okay, thank you. I've used all my time up, and I'm...
Mr. Wentz, if you have questions that are along the lines that you need to finish up, please go ahead and do that.
Well, okay. Thank you. Chief Whitaker, what type of, I guess, the guidance that is out there for the RF community with respect to triage?
Yeah, and Chief Carnes is describing the START system, simple triage and rapid transport, that has become the industry standard. And he mentioned the red, yellow, green, and black, either tags or ribbons that are used depending on the complexity or depending on the type of severity of the injuries. But the START system is very simple. You don't have to be a paramedic or an EMT because it is so simple, and it's based on a quick evaluation. Even he described you spending 30 seconds to 1 minute. One responder, even spending 30 seconds, could only do in a 10-minute period, 20 victims. But the dead and dying, the red, green, and black, again, based on respirations, perfusion, and mental status, but those that are deceased or obviously in a dying state are left in that position. And that's a hard call for a first responder. Normally, as firefighters, we arrive on the scene, and there's 8 or 10 responders for one patient, and we're able to work those full arrest and those seriously injured, trauma full arrest type patients. But in a mass casualty, the roles are reversed. You may only have a dozen responders for 100 patients. And so you have to do the most good for the most number of people. And that's a difficult decision for those first responders to have to leave someone, or if you don't get to them in time, the yellow become red and the green become yellow, and their condition worsens.
Okay, thank you. Chairman Harrison, thank you for the time for that, and I'll turn it over to Ms. Gibson.
Good evening. We're going to transition now to airplane cabin crashworthiness and occupant protection. Mr. Hooray, if you could please pull up Exhibit 6AB. Mr. Gardlin, I understand you do have a presentation. Please proceed.
Borrow the, yeah. So what I would like to do is very briefly just cover some of the occupant protection.
Is your mic on? And if it is on and it's not working, would one of you all at the front table switch seats with them if the mic isn't operating?
It says on.
Okay, why don't you switch seats with someone in the front row? Thank you very much, Mr. O'Donnell.
Okay, that's working. Okay, so what I would like to do is just give a very brief overview of the regulatory requirements associated with occupant protection. Briefly, what we're really talking about here is mitigating the effects of an accident. Obviously, accident prevention, accident avoidance is the primary safety objective. We don't want to have accidents. But in the event that there are accidents, then we have to take very seriously the need to try and make them as survivable as they possibly can. The accident rate is very low, but we are having an increase in traffic growth. And so given that, it means that even at an extremely low rate, we probably will have accidents. I have a couple of graphs to illustrate that. I won't really spend much time on these. But the FAA has published a couple of reports on trends in accident survivability. I've cited them here. And what they basically show is that the accident rate and the fatality rate in accidents are both dropping, and that the percentage of accidents that are survivable is increasing. But in this case, if we superimpose that at a little bit of a more magnified level with the amount of air traffic, it's pretty clear that there is an increase in traffic and that it's likely that we will see accidents even at a very, very low rate. So from an occupant protection standpoint, we basically try to do three things. First off, direct protection of the occupant through survivability, for protection against injuries, impact survivability. We attempt to make the ability to get out of the airplane as fast as possible. And thirdly, we try to extend the time available for egress as long as possible. So what I've cited here are sections from Title 14 of the Code of Federal Regulations, all of which are in Part 25, applicable to transport category airplanes. I won't attempt to go over each of those regulations, but in terms of what we've done, this is sort of the same thing, but with the elements identified with the associated regulatory changes that we've made. So we've done a number of things in each of the areas. This goes back to approximately the mid-1980s is when a lot of these improvements started. Some of the early changes were made in fire safety, and then occupant injury protection, and then to speed egress from the airplane in the event that there is an accident. This is a more literal summary of those. We've done things for flammability. The large interior surfaces now have to meet a very stringent heat release requirement. Seat cushions have also been addressed, very stringent requirement. We've more recently imposed a requirement for the ability of the airplane to resist penetration of an external fire using insulation that has highly fire-resistant properties. Escape slides themselves are now or have been made heat resistant from the effects of a post-crash fire. We've implemented changes to markings, to access to exits, and to the capability of escape slides to make it faster to evacuate. In terms of occupant protection, one of the big changes was imposing requirements for dynamic testing of seats and including quantitative occupant injury protection criteria. And in addition, we increased some of the static load factors on other items in the airplane as well. We've also done a lot of things to address in-flight fire safety, but that tends to fall more into the realm of accident prevention or accident avoidance. So I don't intend to really spend any time on that. Just some examples over the last 8 years of airplanes where there were accidents where we've had a hull loss, but there was in fact 100% survivability in the accident. And then actually I'm running a little bit ahead, but to summarize, I guess, accidents, they are very rare, but for at least the foreseeable future, we will probably continue to have them. However, they are more survivable than ever, and recent experience, by virtue of something like that, suggests that a lot of the changes that we've made over the last several years are actually having a positive effect, and that we're seeing much improved survivability in accidents that might not have been had they occurred earlier.
Thank you. I think because you all have presentations and then we're going to go into a line of questioning, we're going to have you guys move from the back row to the front row. And Mr. Hooray, if you could please bring up Exhibit 8AC. Mr. Deweese, understand that you have a presentation. You proceed.
Yes, I do. Thank you. I've prepared a presentation summarizing the crash safety requirements for transport aircraft seats. The FAA has established safety requirements for aircraft seats that they're intended to reduce the risk of injury and death in a severe but survivable crash. Their requirements consist of static load factors applicable to most interior components and dynamic tests to verify both seat strength and the occupant impact protection. Design requirements are also levied for specific seat configurations. Static requirements have been in place for many years and are intended to protect the occupants in a minor crash landing. Usually expressed in terms of multiples of an item's weight, commonly referred to as G's. The magnitude of the load direction has been increased over the years as aircraft technology has changed. We have a table here summarizing the load factors in the various directions for transport aircraft. They're applied in all directions, and with the highest level being the 9G forward direction. Now, the strength of seats and restraints are verified statically by applying loads slowly. Basically, a body block is strapped into the seat using the restraint system, and then the loads are applied to the body block, as you can see here. Now, accident studies were conducted to look at the accidents that were occurring, and it indicated that survivable crashes can exceed the severity level corresponding to the required static load factors. The predominant force vectors in these cases studied were forward, and then a combined vertical and forward direction. Dynamic tests that confirm that seats designed to meet only the static load factors didn't provide a high level of safety when they were subjected to a severe but survivable impact level. Can you advance to the next slide, please? My clicker isn't working. Basically, laboratory tests revealed that many seats that were designed to meet the static load factors did not perform well when dynamically tested. A video is supposed to play here. Here we go. This is a seat that had passed the static tests. And you can see here it's multiple failures occurred. The seat tore loose from its mounting point to the floor, and the seat belt for the occupant in the rear row failed. To provide protection in these severe but survivable crashes, requirements were implemented to evaluate occupant protection in the two most likely impact scenarios. We have the horizontal direction with at a 10-degree yaw at a 16G peak acceleration, and then the combined vertical horizontal, essentially a 30-degree pitch condition at a 14G peak acceleration. Have the next slide, please. Here we have an example of a horizontal test. Has a 10-degree yaw. The floor for the front seat is deformed, as sometimes occurs in an airplane crash. This evaluates the seat strength and flexibility, along with chest, head, and leg injury protection. That's being evaluated by the test dummy in the second row. Next slide, please. This is an example of the combined horizontal-vertical orientation test. Essentially 30 degrees from vertical. It evaluates the seat strength, particularly the seat pan and the supporting structure under the occupant, and directly assesses the spine injury protection by instruments inside the test dummy. You have the next slide, please. In both these tests, test dummies are used as occupants. This gives us a realistic loading for the seat and the restraint systems, and the instruments inside provide a quantitative assessment of injury severity. The risk of injury from an out-of-position belt is also evaluated during dynamic testing, as is the shoulder belt tension. It has to be limited to specific levels. The criteria that are used to evaluate these injuries permit evaluation of the head, chest, spine, and legs, and these all come from readings inside the test dummy that we're able to interpret using these injury criteria. Now, new types of seats and restraint systems that weren't specifically addressed by the original requirements, they have to also provide the equivalent level of safety when compared to the other standard seats and restraint systems. And this is done by conducting research to derive the appropriate requirements, and then the FAA issues special conditions to implement these new requirements. Next slide, please. Inflatable restraints, in this case belt-mounted airbags, are an example of a new technology that was addressed by issuance of these special conditions. You can see here the bag deploys from the belt and gets between the occupant and the seat in front, lowering the head injury potential. And all these requirements I've been discussing stem from the regulations I've cited here. Thank you.
Mr. Hurray, could you please pull up Exhibit 6W? Mr. Wallace, I understand you have a presentation. Please proceed.
I'd like to start off by thanking the board for allowing me the opportunity to participate in this panel. My name is Bruce Wallace. I am an associate technical fellow for the Evacuation Systems Engineering at the Boeing Company. I'm a member of the NTSB Survival Factors team for this accident and participated in the on-site investigation after the crash. I want to take a moment and express Boeing's condolences to the families who lost loved ones in this accident. Our thoughts are also with those injured, and we wish them a speedy recovery. For Boeing, safety is our top priority, and we strive every day to make flying as safe as possible. In this presentation, I'll briefly describe key events in the impact sequence, and then I'll give an overview of the 777 design features that contributed to the occupant protection during a crash and how they performed in this accident. This graphic shows the position of the airplane during the initial impact when the main landing gear and aft fuselage hit the seawall at over 100 knots. The severe impact loads caused the main landing gear to separate from the wings. The impact also resulted in extensive damage to the aft fuselage structure and separation of the tail. The aft galley, one large cargo container, and a great deal of baggage were released onto the runway. The airplane continued to travel down the runway, resting on the nose gear and the engines. As the airplane continued down the runway, the left engine separated and the airplane became partially airborne. With the nose gear in contact with the ground, the airplane rotated counterclockwise approximately 330 degrees and impacted the ground in a downward and sideways direction. As the airplane slid to a stop, the lower fuselage was peeled open toward the right side of the airplane. The right engine separated, came to rest next to the fuselage. A fire ignited in the right engine oil tank outside the fuselage. From video review of the accident, black smoke can first be seen coming out of door 1 left approximately 15 minutes after the airplane came to stop. 2 escape slides inflated inside the cabin, but all passengers and crew were evacuated from the airplane using alternate exits. This does not diminish the fact that there were fatalities and injuries. Now I'm going to turn to an overview of how Boeing designs the 777 for occupant safety in an accident and how this airplane performed during the accident. The industry's work on airplane safety and survivability of airplane interiors emphasizes 3 areas: surviving an impact, surviving a fire, and airplane evacuation. Keeping the severity of the multiple impacts in this accident in mind, the airplane performed extremely well with respect to each of these goals during this accident. As I mentioned, the first safety design goal is to allow the occupants to survive an impact. The FAA has established certification requirements for emergency landing forces as well as dynamic flight and ground loads that airplane must be able to withstand. The 777 fuselage and interior structure are designed to meet or exceed those certification requirements. Airplane seats and restraints are subject to those same requirements, plus additional static and dynamic load certification requirements, including a 16 forward dynamic load and a 14G downward dynamic load, as Rick had pointed out. The airplane performed extremely well during the impact sequence despite being subject to several severe impacts that likely exceeded the design goals. The passenger seating area remained intact and the overhead stove bins did not fall on passengers or block their evacuation. The next safety design goal is to allow the occupants to survive a post-crash fire, should one occur. The 777 fire protection features included engines and main landing gear that are designed to separate under high impact loads to prevent a fuel tank rupture. If a fire occurs, insulation blankets and cabin materials are designed to resist the spread of fire. In this accident, the main landing gear and the engine separated as designed and the fuel tanks did not rupture. Although a fire did occur in the right engine oil tank, its propagation was slowed significantly to allow for evacuation of all passengers and crew. The third safety goal is to allow occupants to evacuate the airplane. The 777-200 is designed and tested to allow up to 440 occupants to evacuate within 90 seconds. This 90-second evacuation standard is required by FAA regulations, and the testing is done with half the exits blocked and under nighttime emergency lighting conditions. Some of the features that expedite evacuation are simple operation doors, seats and other interior components designed to stay secure and not block the aisles, and automatic self-inflating escape slides. Despite the extensive structural damage to the airplane in this accident, the doors opened, the seats and interior components stayed clear of the aisles, and the occupants were evacuated from the airplane. It is difficult to foresee and design to all possible events that may occur during an airplane accident. This accident included multiple extremely severe impacts that exceeded the design and certification requirements. Despite this, the 777 occupant safety features performed extremely well and contributed to the high survival rate. This performance of the 777 airplane highlights the benefits of the work that the regulators, operators, and suppliers have done, along with Boeing, to increase airplane safety and accident survivability. Thank you.
Thank you. Mr. Hooray, could you please pull up Exhibit 6AA? And Mr. O'Donnell, I understand you have a presentation.
Yes, we do. Thank you, Ms. Gibson. I'd also like to take the opportunity to thank the board for air cruisers to participate in this process. So I'm going to provide a presentation, a background of our company, and also evacuation systems and what it takes to certify them. So air cruisers started in 1929 as a maker of aviation safety equipment. Back in World War II, we made the late Mae West life preservers and barrage balloons. We actually invented the inflatable evacuation system in the 1950s. We were purchased by Zodiac in 1987 and became Zodiac Aerospace in 2007. So what is an evacuation side? It's a safety device that rapidly inflates for emergency evacuation from an aircraft. It's required on commercial aircraft when the sill height exceeds 6 feet from the ground. It's normally installed inside the cabin on the door or housed in an external fuselage compartment. Many slides also double as slide rafts in water landings, as you can see on the bottom from the Hudson incident. There are several primary major components on slides. You have the packboard and lacing cover that contains the slide assembly and provides the mounting hardware to attach to the aircraft door. Then we have the inflatable tube structure, and then the inflation system, which is comprised of a compressed gas reservoir, a valve regulator, hoses, and aspirators. And also for slide rafts, we have a survival kit, which also includes a raft canopy, as you can see at the bottom. Some of the typical slide particulars include, there's a view there at the left of the back of the packboard. You can see at the lower edge the attachment fittings. At the top, there's a top latch, so there's 3 points in the 777 that attach the packboard to the aircraft. At the bottom, you see a girt, which actually attaches the inflatable to the girt bar, and the girt bar then attaches to the aircraft floor fitting. So how does an evacuation slide work? Well, the packed slide system is installed on the aircraft door. The girt bar is attached to the aircraft floor fittings, as you can see in the middle picture. When the aircraft door is armed and opened, a cable is tensioned that releases the slide pack from its packboard. The pack then begins to drop downward, and the inflation cable is pulled, opening the valve to initiate inflation. Once inflation starts, gas rushes to the aspirators, opening the flappers, which then entrain ambient air. We actually entrain about 2/3 of the air into an inflatable from the ambient conditions. The unfolding of the slide occurs in stages controlled by frangible links, as you can see in the pictures on the right. The aspirator flappers close when the pressure builds to about 2 psi. The slide is rapidly inflated and immediately ready for use once fully extended. So what are the requirements? Well, the primary governing document is the FAA TSO C69C. To develop and qualify and certify a slide system typically takes 3 to 4 years. Some of the requirements of the TSO include inflation time. The slide has to inflate within a maximum of 6 seconds. evacuation rate, it has to be able to handle at least 70 people per minute per lane. So for a 777 with 2 lanes, that means 140 people per minute minimum. Has to be able to deploy in 25-knot winds from any direction. Also resist the environment, which we look at sand, dust, salt spray, fluids, etc. Like we said earlier, we also have to have radiant heat reflective fabric. That started in 1983. We have to meet all the flame resistance and smoke and toxicity requirements for the FARs. We have to be able to deploy the unit after it's soaked overnight at minus 40 degrees, and also when it's soaked overnight at plus 160 degrees. And the slides also have to function at adverse attitudes. That's any combination of the landing gears out. And for potential water ditching, we have to be able to prove that the slides do work in that condition as well, and even if it's deflated as a chute. In addition to the TSO requirements, we have FAR requirements and we have OEM requirements, including vibration, shock, on-aircraft repeatability, full-scale evacuation demonstration, and also acceleration loads. You'll see at the bottom right, there's a CAD depiction of the centrifuge testing that our systems go through. And our systems go through that testing to prove that they can meet the anticipated crash loads, but then afterwards, we also have to test the systems to make sure they can deploy after the crash loads have been occurred. So thank you.
Thank you. I'd like to talk more about the occupant protection concept that Mr. Garland showed in his presentation, Exhibit 6AB, slide number 6, and how FAA regulations and guidance keep passengers safe on aircraft. Mr.
Ms.
Garland.
Gibson, you know what? If you don't mind, while they're getting that ready, let's just take a 5-minute stretch break. I know everyone's struggling a little bit right now, and so we're going to just take a really quick 5-minute stretch break. We want everyone to be able to pay attention to panels 4 and 5. We're adjourned for 5 minutes.
Put it underneath. So it will work all the way.
Testing, 1, 2, 3. Testing, testing. Testing, 1, 2, 3. That's better than before. Testing, testing. Testing, 1, 2, 3. That's good, right there. Right. Testing, 1, 2, 3.
Testing 1 2 testing 1 2 testing.
Test 1 2 test.
Testing 1 2 testing 1 2 testing 1 2 testing. This is a test. Testing 1 2.
If everyone can take their seats, we're about to resume. Welcome back. Ms. Gibson, thank you, and we look forward to hearing your questions for the panel.
Wait for Mr. Garland. Thanks. Mr. Garland, Amendment 25-6497 addresses static load testing. What is the static load testing for most interior components? What does that mean?
Well, as Mr. DeWeese discussed, there are both static and dynamic test requirements, or dynamic and static load requirements. Virtually everything that's in the any significant item of mass inside the fuselage is required to be restrained to a given set of static load conditions, and we saw that chart there on what all of those are.
Mr. Gardlin, can you pull the mic a little closer?
Yeah. Or sit closer. So the static load cases basically apply to everything inside the fuselage, including things like overhead bins, closets, galleys, the inserts that go into galleys, and the seats as well. So it's a means of assuring that they have adequate strength.
What are the interior component design requirements?
Well, in addition to things like static load factors and restraint, there are flammability requirements for, again, virtually everything that's in the fuselage. There may be requirements associated with egress, depending upon where something is located. If it's located in an egress path, there may be certain considerations that apply to make sure that we have adequate access to exits and so on. So those would be, I guess, the three main things that would apply to those items.
Okay, thank you. Are interior components subjected to dynamic load testing?
In general, they're not. There is some exception if an item is associated with a seat and forms an element of the seat's ability to perform its function, then it could be subject to dynamic testing. But in general, they are not.
Why not? What are the drawbacks from doing those tests?
I don't know if it's drawbacks. I mean, obviously the dynamic test is a more complex test, and depending upon what you're trying to test, there might be logistical issues with doing it. But I think the main reason is that most things can be substantiated adequately through a showing of strength through a static load, and the issues that would be addressed in a dynamic test really don't come into play.
Mr. Dweese, what are the performance requirements for aircraft seats?
Well, as I showed in the presentation earlier, the aircraft seats have to meet both the static test requirements outlined in 25561 and the dynamic testing requirements called out in 25562.
Okay. How do you verify seat strength and occupant impact protection?
Well, again, the seat strength is through the static test, and then the dynamic test applies the load, more load in a rapidly applied fashion because of the dynamic nature of that test. So that verifies the strength of the seat actually two ways. Now, occupant protection is only evaluated during the dynamic test, and that's evaluated using the readings from the test dummy and observation of how the belts restrain the occupant.
Okay. Mr. Wallace, how does Boeing meet the certification requirements for aircraft seats?
So survivability is greatly influenced from seat design. The 777 seats themselves are designed, manufactured, and tested by our seat suppliers. We work directly with them to ensure that they meet the criteria that has been spoken over here, the safety standards as spoken by the FAA here, as it installed in the airplane. So we take our seat systems and do test them in these sled tests to demonstrate that we can meet those G-forces.
Mr. Dweese, there's many new novel seats in aircrafts today, the pod seats, the lay flat seats, etc. How are those certified?
Well, those seats, to the greatest extent possible, have to meet the same standards as any other seat. But when a seat has a novel feature that the regulations don't directly address, then we usually conduct research to determine what the requirement should be to make sure that that seat provides the same level of safety as the regular seats do. Once those requirements are determined, then the FAA publishes those in special conditions that outline what additional items need to be done to show the level of safety is met.
What is a special condition?
Well, it's basically a type of regulation that outlines sometimes it's additional items to be done, additional tests, additional evaluations. Sometimes it actually replaces some parts of the regulation, say doing a test in a different way than it would be done for a normal seat to account for those novel features.
Okay. Some of the seats in the Asiana accident airplane had shoulder harnesses. Why do some seats require shoulder harnesses?
Well, the dynamic testing regulations require that head impact protection be provided for the occupants. Now, it doesn't specify exactly how to do that. It just provides an objective measure looking at the head accelerations from the test dummy. Depending on the seat design, particularly how far apart the passenger rows are, this can be done different ways. If they're close enough together, then the seat back can be used as an effective energy absorber. The person flails over onto the seat back and it absorbs that head impact energy, reducing the risk of injury. If the rows are far enough apart, then the person flailing forward with just a lap belt restraining them would miss the seat in front entirely, again protecting the head from impact. It's those seats that fall in between there, where the seat back is too far away to really be much of an energy absorber, but it's close enough to present a injury risk. That's where something like a shoulder belt or an inflatable restraint system can be used to provide head impact protection.
So why don't all seats have shoulder harnesses?
Well, basically because it's not necessary in most cases to provide the head impact protection. It can be more efficiently provided using the energy absorbing seat back if the seats are close enough together.
Is it more safe or less safe?
Well, there's no doubt that a shoulder restraint or an airbag that would preclude contact with the seat in front, that would provide a higher level of safety than contacting the seat in front for sure. But all of them meet the minimum standards in the regulations.
What methods or considerations exist for certifying aft-facing seats?
Well, aft-facing seats have to meet the same standards as the forward-facing seats, and virtually the same test conditions and everything else.
Would it be better to have aft-facing seats on airplanes?
Well, they certainly have the advantage of spreading the load out on your body more evenly, supporting the body well. But there are some practical considerations that is one reason you really haven't seen them popular on large aircraft. One of the reasons is that since the body would be applying forces much higher on the seat than a lap belt does, now you've got more force going into the seat, from the seat going into the floor. So to keep the floor loads to levels that it can withstand, generally you have to build energy absorption into the seat back. This means that the seat back would need to flex forward some and absorb energy to manage those loads going into the floor. You can imagine that if you have several rows of these seats and they all deflected backwards, you could definitely impede the ability to egress the aircraft. So you would end up probably having to move the seats further apart, reducing the number of rows you could have in the aircraft. So it's, like I say, it's some practical considerations as to why they haven't become popular for passenger seats.
What about side-facing seats?
Well, side-facing seats is another example of one of our where we did research to look at the proper requirements. They're considered a novel installation, and so a whole series of research tests and programs were conducted to determine what the proper requirements should be for side-facing seats. And those accumulated in special conditions that were issued just early this year that provide special tests and evaluations so that the side-facing seats provide just the same level of safety as our forward-facing seats.
Mr. Wallace, in your presentation, you specifically had mentioned passenger seats and restraints are designed to exceed the static and dynamic load certification requirements. Can you explain how you exceed those requirements?
So clarification on that is that we do design, as Jeff was pointing out here, we do design our airplane components and all the items of mass in there too, and 9G static load and 6G. This is a sustained load condition that we design to, and we design to meet or exceed those conditions. So as far as the seats are concerned, in the statement that I started off with, is there's these additional requirements from the FAA. One is on the static load, all components in the airplane are a 3G side load. The seats themselves go up to a 4G side load. In addition to that, we do this dynamic testing of the 16G and 14G to demonstrate that we can protect the occupant. And those kind of dynamic loads, those are an impulse load, immediate load, a little bit different than the static load, which is a sustained load.
Mr. Wallace, were the flight attendant jump seats on the Asiana airplane 9G or 16G?
They were 16G.
How did they perform in this accident?
There was 13 jump seats on this airplane. They were located throughout the airplane at the 4 exit pairs or the 8 exits. We inspected all of the jump seats on scene, and the jump seats at doors 1 through 3 were all intact. The door 1 right had a twisted seat pan, and the door 3 left had some deformity on that seat pan as well, but they were all intact. At door 4, where we lost the aft end of the airplane and a significant amount of floor structure underneath it, 2 of the jump seats did end up out on the runway with the initial damage to the tail end of the airplane. And then there was a 3rd jump seat that ended up right aft of the airplane on the final impact in the final resting zone. So those ones were all in the area of the airplane that was had exceeded the normal 9G forces that we design our components to.
Mr. DeWeese, are flight attendant jump seats subject to the same dynamic testing as passenger seats?
Yes, they in fact meet the exact same requirements as the passenger seats with the forward test and the vertical test.
So if a 16G jump seat is attached to a 9G wall or partition, does it do any good?
Well, you know, it's interesting. There's a common misconception, and it's understandable if you just look at the magnitudes of those two colloquialisms and just explain that the seats that only meet the static tests are commonly referred to as 9G, referring to that forward pull on the seat, and of course 16G seats are the dynamic seats. But in reality, the mismatch isn't there. The 9G test actually ends up being a 12G test because the 9Gs is multiplied by a 133 fitting factor to account for fitting wear that could occur over the life of the seat. And so it's really a 12G static being compared to a 16G dynamic. But it turns out when the 16G rule was being developed, there was a lot of seat tests of prototype seats were done, and essentially what was determined was that the loads imparted into the floor during a 16G forward test did not exceed the floor strength that was required by the 9G static requirement. So there actually is a good match between the loads generated by a seat tested at 16 Gs and the available structural strengths provided by an item that's certified to the 9G requirements.
So when they're tested as a component, as a unit, the jump seat to the wall or the jump seat to the partition?
Well, what's actually done is, as Mr. Garland referred to earlier, if a jump seat's, say, attached to a partition, then that's really considered part of the seat at that point, and the whole thing is tested together dynamically. But if it's attached to something like a galley, a very large item, then essentially what's tested is the attachment points to that item. In other words, a section of the wall of the galley where the jump seat bolts on, that's emulated in the fixturing on the sled when it's tested to make sure that that attachment's good. But the entire galley is not dynamically tested. It's statically qualified once again.
Okay. Mr. Garland, what are the requirements for seat configuration on an airplane?
Well, there's a number of requirements that apply. Most of them, once the seats themselves have been shown to meet the appropriate structural and injury criteria, then the bulk of the rest of the requirements are to ensure that the seats are positioned in a way that allows for egress. There are also requirements, for example, that the seats and the oxygen mask drops line up appropriately. But there's a number of requirements to ensure that there are adequate paths for evacuation leading from each seat row to a passageway to an exit, or in the case of a twin-aisle airplane, to cross aisles that then lead between aisles and then lead to exits. So it defines, I guess, the entire arrangement.
So what is the FAA's role in implementation when an air carrier chooses to reduce spacing and put on more seats?
Well, the FAA basically is responsible for approving that sort of design change, and it's considered a change to the type design of the airplane. Specifically, which part of the FAA that may oversee it, I think, depends in some degree on how extensive the modification is. And so it may be that the FAA's Flight Standards Service looks at that, and maybe that the Aircraft Certification Service looks at that. But it is considered a change, and it requires a full FAA approval.
Thank you. I'm going to switch to evacuation systems now. But for Mr. Garland, what guidance exists for evacuation certification design?
Well, we have advisory circulars. We have advisory circulars on how to conduct the full-scale evacuation demonstration that was alluded to, or in some cases, depending upon the extensiveness of a change, that could be potentially done analytically. We have advisory material that covers the configuration requirements for an airplane, so where seats can be positioned relative to aisles and things like that, how closet doors have to be restrained, for example, so they wouldn't open into an evacuation path. So there's a number of advisory circulars that cover those areas.
Mr. Wallace, Mr. O'Donnell mentioned in his presentation a full-scale test. Can you explain what that is?
Yes, so a full-scale test is, as I mentioned in my presentation, we do demonstrate for the 777 that we can load the airplane up with full configuration, high-density seat configuration. And the full-scale test is a benchmark test that we run for certification to demonstrate the capability of the airplane for egress with that maximum passenger. It's conducted with half of the exits inoperative, and it is a timed event. We do emphasize that there's a sense of urgency to get out, and so the full-scale is taking the whole entire airplane and filling it with people and doing a test.
Mr. Garland, why is the requirement for half of the exits?
Well, as mentioned, it is a benchmark type test. It's a means of comparison against a common standards, so that we have an idea of how efficiently an airplane can be evacuated. The historical precedent for half of the exits dates back 40, maybe 50 years, and I think it's recognition that in an actual evacuation, you may not have all exits available. So as a way of standardizing it, it has been to use 1/2 of the number of exits, and that is done by using one exit from each pair of exits.
Mr. O'Donnell, what kinds of tests are slide rafts subjected to before they are certified?
Like I said in my presentation, the TSO requirements, which are very diligent. I went over those in detail. We also have the dynamic tests, the centrifuge tests. Like I said before, the slide actually has to be put through the 9G and forward and 3G inboard loading on the centrifuge, and then afterwards you have to prove that we can deploy that off the door to make sure it still works.
So the dynamic testing you're referring to, that's the spin test?
That's a centrifuge test, yeah. Some may consider it static, but if you've ever seen it, I wouldn't call it static. But
2 slide rafts inflated inside the cabin. How frequently do you get reports of slide rafts inflating inside cabins?
I have been at air cruisers for 26 years and have never had a report of our product deploying inside an aircraft.
Can you describe the teardown testing that was accomplished in July?
Yes, there were several pack boards and slide rafts returned to air cruisers from San Francisco. I think of note, what was found was that on door 1 right and door 2 right, that inflated inside the aircraft, the pack boards were still on the doors. When we looked at those, or when my team looked at those pack boards in New Jersey, we found out that the release mechanism had actually suffered catastrophic failure. So it was overwhelmed by the forces that were seen during the accident, which then forced the slide to release inboard and then inflated.
Have you ever seen damage like that before in an in-service aircraft or in an aircraft that had been involved in an accident?
We have never seen anything like that after certification tests, and even after the Heathrow test, or crash rather, of the 777 several years ago that Bruce was at. The release mechanisms did not suffer that sort of failure.
Mr. Wallace, then, has Boeing ever seen a 777 accident where there was damage similar to what we saw?
No, I haven't. Haven't seen that in occurrence in any of our in-service reported cases, or with like you mentioned here, in any accident that we've seen, we haven't seen that kind of damage.
The damage that you saw here with Asiana, how does that compare to the Heathrow accident?
Damage to the slide or the airplane?
The airplane.
The airplane? That airplane was totally intact. The difference between these two is that airplane, if anybody's familiar with it, in Heathrow, it lost power coming up to landing, so it did crash in short of the runway. The fuselage and all the interiors were all intact, seats were intact, and it was in pretty decent shape. All the slides did deploy. The difference here is that we did have an impact that was more of a vertical impact versus the horizontal when we hit the seawall. So it did hit the tail end in a vertical type impact rather than in a horizontal. In addition to that, once it did go through its rotation, its final impact was still going down the runway, and there was, in looking at the video, there was a significant down and side load of the airplane that is not typical for what we've seen with accidents.
Mr. O'Donnell, what did you find in the tinsel test?
When we took brand new pack boards and subjected them to tensile testing to try to recreate the failure that we saw in the release mechanism, we saw loads that were orders of magnitude higher than what we would have expected based on our centrifuge testing.
So how does that compare to the certification loads that you test to?
I don't want to draw conclusions. They were orders of magnitude higher, so they were, I would say, at least 3 to 4 times higher.
Mr. Wallace, was this type of impact sequence something Boeing envisioned during certification testing?
No, as I mentioned, we do follow the safety standards that have been developed by the industry and are and that the FAA imposes on us. And judging by the accident, it's hard to say. We are still under investigation. We do have another planned test for our slides so that we can hopefully determine what the final failure mode was for that. So further investigation, we'll see if there's something that we learned from this accident that might be able to use towards our safety improvements.
Mr. O'Donnell, what sort of challenge would you have to meet a higher threshold if you were to increase the G loads that you test to?
Basically would involve the release mechanism and the release shaft material. So we've already done some brainstorming with our engineers in that regard, but it's premature to really look at anything until we finish up the testing that will be occurring in January.
Based on the ongoing testing, has Air Cruisers made any changes to the pack design or testing?
No, we haven't, because it's premature based on the investigation that's still ongoing.
Mr. Wallace, despite multiple severe impact loads, we do not see the overhead bins fall on passengers in the Asiana accident. Has Boeing done something different with their design?
So, as mentioned, over time as we evaluate airplane accidents, we do discover areas of improvement, and stow bins are one of those. The stow bins themselves are also designed to the 9G forward, 6G down, 3G side, 3G up, and 1.5G aft. In addition to that, we do have some flight and ground loads that increase the up and down loads. So we design our stow bins to meet that. In addition, the stow bins are tested to demonstrate that they can withstand that.
I'm going to go back to Mr. DeWeese. You had mentioned inflatable restraints. Will all aircraft be equipped with this new technology?
Well, at this point, the inflatable restraints are being used for those seat positions where a conventional means of providing head protection, i.e. the motion of the seat back where the occupant pushes it over, isn't available, say a front row or seats with long pitch. So there's no actual requirement envisioned to require airbags for all aircraft. That being said, they certainly do provide a higher level of safety, and if operators wish to incorporate them, they could certainly have a great impact on survivability.
Mr. Garland, so where are we going from here? Are we stagnant? Are we evolving? What are the challenges that you see?
Well, actually, since you mentioned that, we had probably almost 600 people discussing that very issue last week at a large R&D conference on occupant survivability. Well, as you can probably imagine, in the course of trying to make improvements, we've prioritized those activities and tried to do the things that would make the most improvement first, and we've been working our way through that. But no, we're not stagnant. We have initiatives underway to address airframe level crashworthiness. We're looking at means of providing occupant protection or occupant injury criteria that more closely correlate with what we're interested in, which is the ability of someone to evacuate an airplane after an accident. The standards we have now have been, to some extent, read across from automotive standards, and they're valid standards, but they're not specifically geared to the problem that we have. We're looking at novel ways of giving passengers safety information that they might actually assimilate and use. And we have an extensive R&D prioritization process underway that we are hoping to implement that covers all the areas that I mentioned, the 3 different regions. So no, it's not stagnant. We have a lot of work ongoing.
Tim?
Mr. Park?
네, 저는 패널 4의 이머전
I'd like to ask question to the San Francisco Fire Department Chief, Assistant Chief. Is microphone ready? According to the ARF regulation with internal regulation, in its manual, 4 emergency vehicles are required to be operated. In this accident, how many vehicles were dispatched? 네, 헤드셋이 안 돼 있었기 때문에 질문 다시 해주십시오. At the San Francisco airport, according to the internal regulation of the San Francisco International Airport, the manual says that the exhibit O says that it is required to dispatch 4 emergency vehicles. So in this case of accident, how many vehicles were dispatched?
For any alert 3, we dispatch a total of 7 firefighting companies, 2 paramedic units, and 1 command vehicle. The 7 firefighting companies include not only traditional structural engine companies and a truck company, but they also include 4 ARF vehicles.
So how many emergency vehicles were dispatched then? Not fire trucks, I mean emergency vehicle.
Are you referring to medical EMS type vehicles, sir?
Yes, correct.
We have 2 paramedic units on the airport as part of our response, and then an additional 56 ground ambulances came in as part of the mutual aid response.
That's all the tech.
Thank you, Mr. LeBaron. We'll now move to the parties. Asiana Airlines.
Thank you, Madam Chairman. On behalf of Asiana Airlines, I want to take this opportunity to express our sincere appreciation and deep gratitude to the first responders and emergency personnel, and to the medical facilities and medical personnel in the San Francisco area for their efforts and support in responding to this tragic accident. Thank you.
Thank you very much, Captain Kim. Asiana Pilots Union.
If you have no question, thank you, Madam Chairman.
Thank you, Captain Min, for your participation today. Air Cruisers.
Yes, I have just one question for John O'Donnell.
And Mr. Henches, can you just introduce yourself, because I know folks have been looking to Mr. O'Donnell for the...
Yes, my name is Robert Henches. I am the Boeing program manager for our Boeing products at Air Cruisers.
And you'll be acting as the party spokesperson since your spokesperson is on the witness stand.
Yes, that is
right.
Correct. Okay, Mr. O'Donnell, shortly after the Asiana crash, some media outlets were bringing up the fact that some 777 escape slide systems were subject of an airworthiness directive from the FAA. Can you talk about that airworthiness directive and whether it had any bearing on the escape slides on that particular aircraft?
Yes, that AD was in reference to the release mechanisms on the pack boards. It was a service bulletin that we put out, and the FAA made it an AD at our recommendation as well because of corrosion. So the AD said to inspect the pack boards. If there was corrosion, to replace the housing with a new allodyne housing.
So when we looked at what occurred on the Asiana aircraft, 6 of the 8 had the new blue housings and no corrosion, and the other 2 were of the original design, but they also had no corrosion, so the corrosion played no role at all in what occurred.
Okay, thank you. No further questions.
Boeing.
Thank you, Chairman Hersman. Boeing has no questions.
Thank you, Ms. Burdenson, for your participation today. City and County of San Francisco.
We have no questions for the panel. Thank you.
Mr. McCoy, you're 5 for 5 today. Thank you.
Good answers.
Yeah. And finally, the FAA.
Madam Chairman, FAA has no questions.
Mr. Drake, thank you for your service as party spokesperson. We'll now move to the board members. Member Sunwalt.
Madam Chairman, you were nice enough to give me extra time on one of the panels, so I've promised that I won't ask questions for this panel. So
Thank you. I wanted to make sure everyone understood that you weren't going to ask questions to the panel.
I think everybody's glad I'm not going to ask questions. Thank you for your service, Madam Chairman. Thank you.
Member Weiner.
Well, this is an unusual situation.
This is your wake-up auto throttle time, Member Weiner.
Both Mr. Gardland and Mr. Wallace said there were 3 things that were important, and they're pretty much the same thing: occupant protection, exit speed, and time to exit. So in terms of occupant protection, Mr. Wallace, did you see that the 16G seats performed as expected?
So as mentioned, the 16G seats are designed to protect the occupants in a survivable crash. The seats that were up in the what we call zones A and B. Zone A is between door 1 and door 2, and zone B is door 2 to door 3. They were all badly damaged by fire, but they did all the seat legs themselves that we could inspect were still mounted to the floor tracks. The zone C, where we had the significant structural damage, the seats were pretty, in general, they were leaned back. Some of the legs had come loose or been fractured. There was a lot of legs bent to the left. The overall seats themselves, since we had lost the lower portion of the fuselage back there, the floor that supports those things was kind of pushed up on one side, on the right side. It was very badly damaged. So as far as meeting a 16G, without that structure, it's difficult for it to, really consider whether it it had demonstrated to meet those criteria. So as a result of the damage and the fact that they were still able to protect many of the occupants, they performed pretty well considering the damage to the airplane.
Were the seats in Zone C damaged in the forward direction, or was there, I thought you said there was a backward movement?
Yeah, it's hard to tell what the forces were on the seats. There was, when we had inspected them, a lot of them had the forward legs had come loose, so they were leaning back. With the floor structure as badly damaged as it is, I can't tell if it was because there was some kind of an aft load to it or how they ended up like that.
The video that we saw earlier today sort of suggests that at least at the aft end of the airplane there may have been a centrifugal force to the rear. Were any of the seats, the bulkhead seats are ones that you are concerned about the head impact criteria. Is that correct?
The bulkhead seats?
Yeah.
The bulkhead seats, I believe, were clear. I'm trying to think of the second. Well, so all the seats in there are designed and tested to demonstrate that they can meet 16G. So whether there's a bulkhead there or not, they've been tested in that configuration. And I'm thinking there's enough.
Were any of those airbag seat belts?
No, they were not.
They were not. In terms of exit speed, the 90-second evacuation demonstration was mentioned as basically a benchmark test. As such, is it done with a typical complement of carry-on luggage, or is it just done people only?
So that test there is some criteria in the safety standards that say that we need to put luggage and some obstacles in the aisleways. So yes, it is representative of luggage in the airplane.
And lastly, in terms of surviving the fire, how did the interior materials perform? This is probably one of the first real opportunities to look at all of those changes that were big back in the mid-'80s for flammability.
Correct. As I mentioned, the first signs of dark smoke coming out of door 1 left was about 15 minutes in, and that would indicate that you've got door 1 left with the attitude of the airplane was the highest point, so the smoke would kind of move that way. But as you mentioned in this accident, the fire was slowed greatly enough that we could get everybody evacuated, including the rescue team, able to get the people that could not get out themselves.
Mr. Garland, anything to add?
Not really. I mean, I think the slow development of the fire does indicate that the materials did what they're supposed to do, and I would agree that the aft end of the airplane probably saw fairly high centripetal acceleration that resulted in some aft load.
Thank you.
Thank you. Member Roskine.
Chief Carnes, I know you're back there.
Yes, sir.
So first question is just, can you give us a sense of how much activity you got going on in the department the year before this accident? I thought I heard you say 10,000 responses a month on fires, or give us a sense of just how busy you are.
Well, the San Francisco Fire Department has 44 stations in the city of San Francisco, and then 3 stations at the airport, and collectively we run approximately 10,000 calls a month. So we're an extremely busy urban fire department. That includes medical aids, fires, technical rescue calls, hazardous materials, airport incidents, and so on.
And specifically for the airport, what do those numbers look like?
I don't have that information immediately available, sir. I'm sorry.
And these are, potentially once-in-a-career kind of activities that happen here. So just trying to get a sense, though, of, your experience in the last year, 5 years even at the airport. This is a standout activity. What other kinds of things have you been dealing with? Just 1 or 2 examples to get a feel for.
Well, I've worked at the airport off and on as an officer since 2008. And since that time, I've not only been on the Asiana 214 crash, but also on the San Bruno gas explosion, where we actually provided mutual aid instead of requesting mutual aid. So even though these are what by most terms would be considered career incidents, because of the environment we work in the Bay Area, we tend to see pretty complex incidents on a regular basis.
The other thing I wanted to ask you is one of us up here at the board meeting, when this comes before, will certainly ask what changes have happened since the accident. And what's interesting, we're at the hearing now, just a step in between, and you had a couple slides there that really listed quite a few initiatives that are going on. So it appears you've had quite a bit of support, including budgetary. You had a 40-hour person going to 24/7, a lot of training initiatives. Can you just tell us a little bit about that? Is that coming from the airport, the city, the county? There's clearly been a lot of push to help you kind of move ahead.
The short answer would be yes. It's coming from both the city and county, the fire department, and my command and administration above me. the airport and both boards, the airport board and the fire board. The city and county of San Francisco and the citizens of our community take a lot of pride in our fire department, and we feel that we have had a world-class organization before the Asiana 214 incident. We certainly plan on continuing that afterwards. Anytime you have an incident of this complexity, regardless of the level of successes that you identify, I think it's just natural to step back and do a comprehensive review of your performance, your capabilities, your training, and look for any opportunity to enhance those things. And that's exactly what we have done and continue to do. Also, in this particular incident, we obviously recognized our overall responsibility to the ARF industry and the nation's, aircraft and airport industry. And because of the low frequencies of these events, that we have to garner as much training value and learning value out of this as we can, and we willingly accepted that responsibility.
A great transition, because we're going to go to Chief Whitaker. Just can you give us any sense briefly, lesson learned for the industry, which is what the chief was just saying, basically. What are the mechanisms available in the industry to make sure that everybody gets to learn from this experience?
Well, the group I represent now, the Aircraft Rescue Firefighters Working Group, represents over 500 airports internationally. And we do take those lessons learned from each of the different incidents, whether they're large or small type incidences, and try to put them in and bring in conferences, presentations. We do 3 or 4 of those type of events a year. We work with other partners, FAA, NTSB, AAAE, other organizations to film and document those presentations and lessons learned, and try to do regional outreach with the training academies.
Great. I have last 2 quick questions for FAA. I didn't know if I could ask this, but Mr. Garland, you showed a slide about the decrease in accidents. So one of the challenges everyone seems to have is you keep pushing more and more for safety, but because the accident rate's going down, the numbers for the cost-benefit justification gets to be harder and harder. FAA, you 2 guys, anything to say just about what those challenges are? And you talked about what's next. Well, how are we going to get there, given how it's a bit of an irony there. The safer you get, the harder it is to make it even safer. Comment?
You're correct.
Okay. Last question is, during the day here, we've been talking a lot about human factors and human performance. And I think it's kind of interesting. We've been talking about all the great advances in the technology, if you will, of occupant protection and firefighting. What about the human factors part of the survivability here? Wear your seatbelt, listen to the safety briefing, know where the exit is. Is there work going on or changes or advances being in that kind of human part of this?
Yeah, there is, in fact, and we have another part of the Civil Aerospace Medical Institute looks at exactly those things. And one of the things that we're focusing on right now is improved and more effective ways of communicating safety information to people so that they actually assimilate it and it becomes second nature. So, yeah, it's an ongoing activity.
And I know you're all familiar with our most wanted list. It's 10 items, and fire safety is on there. January 16th, we'll be announcing 2014. So I was in Philadelphia at that meeting, and I just want to acknowledge that I think there's a tremendous amount, not only of acknowledgement, but congratulations for really the several decades worth of advancements you've made, that we can be in a room now really talking about how those advances have really made a difference in saving lives and preventing injuries. And as tragic as the accident is, part of the lessons learned is, believe it or not, acknowledging how much what you folks have done has made a difference. And I think my last slide was what's next, and I think that's the challenge for you folks, whether it's on the first response or in the prevention side, what's going to be next to see how we reach that next level. So thanks to all of you for that.
Vice Chairman.
Thank you. I'm going to follow along the line of lessons learned questioning that Member Rosekind started and ask the same question of the FAA as a regulator and Boeing as a manufacturer. This is obviously a very rare event, thankfully, and were there any lessons learned for either of you in your respective capacities from this event? Start with the FAA.
I think at this point, the the fact that the investigation is still underway and there's a lot of details that are not completely finalized, I probably would reserve judgment on what lessons we've learned. But certainly the impact sequences was not something that we'd seen before, and so that's something that I think we'll have to consider the nature of impact sequences a little bit.
Okay, thank you. We'll stay tuned for that. I guess, Boeing, you may be saying the same thing, but I'd be interested in hearing your response.
Yes, it is the same answer. As you know, in our previous discussions, that these kind of events, working with the NTSB, the FAA, and the other people involved in this, we do learn things when we have an accident. This one was very severe, but we expect that the investigation is ongoing, and certainly once we kind of conclude to this, there'll be an opportunity to see if there's any areas for improvement.
Okay, thank you. That's all I have. Thank you very much for your participation.
I have a question about the different types of seats that were in the 777 involved in this accident. We had 3-point belts in the first class or business section versus 2-point belts back in the economy. Is there a difference with respect to passenger protection or survivability when it comes to those two seating configurations? Boeing could take that if they'd like.
So as been discussed here, one thing is that the business class seats themselves were installed after delivery for us, so we don't know the details of the design or anything, but in the business class, as Rick was pointing out, there may be some orientation of the seats or some extra obstacles in the way that would require them to have a shoulder harness. And we do this so that we can provide the same safety benefit that we're getting in the economy section as far as meeting the criteria and the safety standards that we have.
Okay, so the bottom line is both seats are required to meet the same criteria?
That is correct.
Okay. What do we know about the seatbelt use rate for passengers on aircraft and the compliance? Do we have any passengers in this flight who we know were not wearing their seatbelts, or who we suspect were not wearing their seatbelts?
Yeah, there was some interviews with some passengers that indicated that that persons were not wearing their seatbelt, and another one had indicated that there was a blanket over their lap, so they didn't know.
Okay, so Mr. Wallace, I think with those interviews, what we're talking about is we're talking about some of the fatalities, and so maybe we could be a little bit more clear about that, because those interviews are available. So we had one of the fatalities that there was the possibility that they weren't wearing a seatbelt because they were covered with a blanket.
That is correct.
And the other one was confirmed not wearing their seatbelt?
That was the response from one of the other passengers, yes, correct.
Okay. And the area where we saw the fatalities, the fatal passengers, what part of the aircraft was that?
They were in the very aft, row 30 or row 41 and 42.
And that was where the most significant structural damage to the aircraft was?
That is correct.
Okay. I would like to move to Assistant Deputy Chief Carnes. You had a presentation that you provided to 6V, and in your presentation you listed successes and challenges, and if I could get the page that references the challenges pulled up. There was a major issue with respect to the on-scene response. There was a passenger who was run over, and so can you, when I look at the challenges section, I was surprised not to see something with respect to how you dealt with that. So maybe that's contained within one of these other areas?
We do, in fact, consider that's a challenge, ma'am, and we actually do reference that we are working on developing strategies to limit the potential firefighting vehicles striking or impacting accident victims.
So along the lines of lessons learned, kind of help me understand in your post-accident review, what your determination was. Certainly, part of what we're doing here is educational for other firefighting communities around the country at different airports. What were some of the lessons learned for you all that came out?
Well, one of the lessons learned is that there does not appear at this time to be an industry standard or best practice on limiting or avoiding secondary strikes. We have reached out to multiple other ARF agencies, other indexee chiefs. We are currently continuing to pursue that and also work with our coroner's office. Every ARF incident is different and unique, and they're very complex. You're dealing with very large apparatus that are required to get in very close to a burning aircraft in order to do their job and facilitate rescue. It's a situation where it's a very complex situation, and whatever solution we come up with will be multi-layered and will be situationally dependent. We'll have to be flexible enough to deal with the multiple types of scenarios we face within the ARF community.
Are there specific procedures for marking victims that are found in a debris field?
In this case, it was a matter of my personnel recognizing that they had an obviously deceased victim, and based on their training and their experience making that recognition, at least 3 of my firefighters independently made the same observation, and each one of the personnel that recognized the deceased then immediately, based on their training and our protocols, defaulted to the higher priority of effecting rescue of trapped victims in a burning aircraft. With 23 personnel on scene and, again, having multiple trapped victims inside the aircraft, even if we had a system to mark the deceased, it wouldn't have been appropriate to take the time to do that at that point. They had to default to the rescue in order to prevent further loss of life.
And I think we all appreciate the work that was done. There were 300 people that walked away. There was a lot of successes here, and I think when you all talked about triage, it was doing the most good for the most people in the shortest amount of time. But I think certainly in this case, there's one person who didn't get the treatment that I know that you all would want and that we would expect in a situation. So understanding what happened, I think, is important for all of us. These are big apparatus. You talked about limited visibility in difficult conditions. What are some of the ways that this type of event could be prevented? Are we talking about spotters or visibility cameras to see more? What are we talking about here?
Again, we already had a spotter. We refer to our second and third personnel on our ARF rigs as riders. Their responsibility is to work as a second set of eyes and also work as a ground guide when needed. And certainly you can see that in some of the footage from our cameras on our vehicles. However, because, again, of the pressing need to extricate trapped victims from the aircraft, our riders were eventually pressed into service inside the aircraft, leaving our drivers by themselves. If I may for a moment, let me put you in the cab of one of our rigs in that environment. You're talking about, again, a very dynamic and complex environment. You're having to maneuver your apparatus very close to aircraft. You're not only responsible for driving that apparatus, but you're carrying out a very technical, multifaceted operation, operating your high-reach extendable turret, your nozzles, delivering your agents appropriately. And even though we do have cameras, I can honestly tell you that as the operator, your focus is on the task at hand in supporting your crews on the inside and delivering that agent and maneuvering up close to that aircraft. So I think that this was, while we definitely regret the additional insult to the deceased, and I can attest that as professional rescuers, every life to us is critical. This is a matter of certainly not of us being careless or callous, either one. It was the fact that we were dealing with a very complex and dynamic environment, and we were very much focused on the priority at hand, and that was saving as many lives as possible.
Thank you. I think we certainly understand that any post-accident crash environment where you've got a lot of victims, survivors, people who are injured, is going to be very dynamic. And so I think our interest here is just making sure that we learn the lessons and make sure that we share them with the community. So thank you.
We agree.
Okay. Are there any additional questions from the parties? From the tech panel? Oh, I'm sorry. Captain Kim, did you have a question? Oh, no questions. Okay.
We have none.
Mr. LeBrun? Nope. No further questions from the board members? Very well. I think since we have no other witnesses to testify, the NTSB's investigative hearing into the crash of Asiana Flight 214 at San Francisco International Airport is concluded. The record will remain open for additional materials requested during the hearing. On behalf of my fellow board members and all of the NTSB staff, we extend our appreciation to all of the participants at the hearing. I thank each of the witnesses for their testimony and the party spokespersons for their cooperation, which is essential to all aspects of our investigation, and it was particularly evident here at this hearing today with all of the diverse and willing participants. I'd like to acknowledge the staff from the NTSB's Office of Aviation Safety and the support of the staff from offices across the NTSB. The transcript is scheduled to be available to the parties and the witnesses electronically within 7 days. Any corrections to the transcript by the witnesses or the parties should be sent to the hearing officer, Mr. Tim LeBaron, within 30 days of receipt of the transcript, which should be on about January 18th, 2014. Any documents or information identified during the hearing that a party agrees to furnish to the NTSB should also be provided by that same date, January 18th, 2014, to our hearing officer. The archive of the hearing webcast will remain on the NTSB website. That webcast will also be archived in Korean and Mandarin as well. The transcript of the hearing and all of the materials entered into the record will become part of the public docket along with all of the other records of the investigation. Today we have shined a valuable light on the facts and the circumstances of July 6th. Our investigation is ongoing, and we will continue to work diligently to finalize our report. Commercial aviation has never been safer than it is today, and we owe many of the advances in aviation safety to advances in cockpit automation. However, automation must be well understood and monitored effectively by flight crews. Today's hearing has provided our investigators with valuable insight about the specifics of the 777 flight deck, Asiana crew training, and automated systems. While we seek to understand how the 3 passenger fatalities and serious injuries to all on board might have been prevented, we also want to identify the factors that contributed to saving the lives of more than 300 passengers and crew members. Today's testimony has also provided valuable information about crashworthiness and emergency response. More and more, we recognize that aviation is an international endeavor, and we are both dependent and strengthened by our relationships around the globe. Fortunately, we do not have accidents like Asiana 214 very often, but when we do, we are obligated to investigate them, to learn from them, and to determine actions that can be taken to prevent them from occurring in the future. While each witness and each organization represented here brings different knowledge to the table and has a different perspective, everyone here has the same goal: to improve aviation safety. Despite the disruption with yesterday's closure, I would like to recognize everyone who made this hearing possible: our NTSB staff that coordinated a multitude of logistical challenges in a very short time frame. And I have to take my hats off to the interpreters who have a tough task under normal conditions, but under a long day like today, I believe their challenges were doubled. I would like to acknowledge the more than 20 witnesses who accommodated the late change in schedule and came well prepared to testify. And finally, I would like to recognize Chairman Cho for making the long journey here from Korea to attend this hearing. His effort to travel and be here in person is a testament to the great cooperation among our foreign partners and the shared desire to make aviation safer. We stand adjourned.